Hello everyone. In this lesson, we are going to study the classification of organic compound based on their structure. In the previous lesson, we have learnt the classification of organic compound based on their function. We can classify the organic compounds in different manner. This is one of the way you can classify them. The main purpose of classification is to understand easy way of learning organic compounds. Since you know that organic compounds are huge in number, in order to study all the organic compound, so we have to classify so that systematically we can reduce the burden of learning those things. After completing this lesson, you will be understand the different arrangement of carbon atoms in their structure. So the topics that I am going to cover in this lesson are open chain compounds. In that, those open chain compounds may be saturated or unsaturated compounds, closed chain compounds. In the closed chain compounds, it may be homocyclic or heterocyclic. Again, in homocyclic or heterocyclic, they will be alicyclic or they may be aromatic compounds. How the classification of organic compounds is done based on their structure, we are going to consider here. Hydrocarbons are the organic compound which going to contain only carbon and hydrogen. We are going to classify them as hydrocarbon. Apart from carbon and hydrogen, organic compounds may also contain oxygen, nitrogen, sulfur, halogens and metals also. So in that case, we are going to classify the organic compound into pure hydrocarbons and apart from hydrocarbon, other class of organic compounds. Hydrocarbons are a class of organic compounds which are made up of only carbon and hydrogen. So they can be joined through a covalent bond either in a single bond to form a open chain and a long chain without any branching, or it may be branching also. So here your compound going to contain only two elements. One is carbon, other one is hydrogen. The linking may be open chain which are straight chain, other one open chain with a branch hydrocarbons. Again, other hydrocarbons, organic compounds are there apart from carbon and hydrogen. They are classified into two main streams as open chain, acyclic, closed or cyclic. As the name indicates, open chain means they are open in nature. They are not cyclic in nature, acyclic. Other one closed or cyclic. So, open chain are acyclic, they are not cyclic in nature. Those are the compounds initially we are going to know them as aliphatic hydrocarbons because these class of compounds are obtained from animal or vegetable fats. Aliphatic. Therefore, we are going to call them as aliphatic compounds. Aliphatic means it's a Greek word. Aliphate means fat. So, carbon atoms are present in the form of the open chain. There is the terminal carbon atoms are not linked together to form a ring. Such hydrocarbons are called as open chain compounds. Those open chain compounds are further classified into two categories. One is called as saturated, other one is called as unsaturated. Saturated means carbon-carbon bond is satisfied by a single bond. Those are called as saturated hydrocarbons and we are going to call them as alkanes. Unsaturated hydrocarbon means carbon-carbon bonds are satisfied by either double bond or by a triple bond. If they are satisfied by a double bond, they are called as alkenes. If they are satisfied by a triple bond, they are called as alkynes. These chains may be again either a straight chain or branched chain. Straight chain means there won't be any branches. Simply they will be in the form of a straight line. Such hydrocarbons are called as straight chain hydrocarbons. Branched chain means again there may be a branching at any carbon atom. So such hydrocarbons are called as branched chain hydrocarbon. Open chain hydrocarbons are classified into saturated and unsaturated. Again, those unsaturated or saturated are further classified as straight chain or branched chain compound based on their arrangement of atoms. If they are going to form a long chain like structure without any branching, they are called as open chain hydrocarbons. If there is a branching, they are called as branched chain hydrocarbons. Alkenes, as I already told you, they going to have the general formula CnH2n plus 2 where n is an integer. Here carbon-carbon bond is satisfied by a single bond. They will be they are in the form of sp3 hybridized. They are also called as paraffins. Again, it's a Latin word. Para means little, affins means affinity. They are going to have very little affinity because they are satisfied by a single bond. Therefore, they generally do not undergo chemical reaction. They are going to have low chemical activity. The main sources of alkanes are petroleum or natural gas. The main constituent of natural gas is methane, which is alkane in nature. So another class which are called as unsaturated hydrocarbons, in which the carbon-carbon bond is satisfied by a double bond. Those are called as alkenes, and they are going to have the general formula CnH2n, and they are called as olefins because these are the oil forming compounds. In alkenes, carbon-carbon bond is sp2 hybridized and they are going to have a planar structure. So these are the classification of hydrocarbons based on their structure. If they are going to have a single bond, we are going to call them as a saturated or alkanes. If they are unsaturated with a double bond, then we are going to call it as a alkenes. If they are unsaturated with a triple bond, then we are going to call it as alkynes. Alkynes are unsaturated hydrocarbons containing carbon-carbon triple bonds. They have the general formula CnH2n minus 2 and the carbon-carbon bond is satisfied by a sp hybridized carbon. The first member is acetylene. So similarly, when you consider the closed chain or cyclic, they are, as the name indicates, they are cyclic in nature. They are going to form a ring-like structure. They are marked by the presence of one or more closed ring-like structure. So again further they are classified into two types. One is called as the homocyclic, other one is called as the heterocyclic. Both of them are, no doubt, they are cyclic in nature, but homo means they are made up of only one type of elements of the ring. They are called as homocyclic. If they are made up of different types of atoms, then we are going to call it as heterocyclic. As the name indicates, homo means same. They are going to contain, they are cyclic in nature. All the elements which are going to form a ring, they are same. Then we are going to call it as a homocyclic. If any, at least one is different, then we are going to call it as heterocyclic. Hetero, different. Homocyclic hydrocarbons are also called as carbocyclic because they are carbon in nature and they are cyclic in nature. That's why they are called as carbocyclic. Here they are going to form a ring-like structure, and the ring of the compound is made up of only one type of atom. Then they are called as homocyclic in nature. Example: cyclobutane, cyclopropane, cyclopentane, cyclohexane, benzene, naphthalene. All these are example. Similarly, you are going to have heterocyclic compounds. No doubt that they are cyclic in nature, but the ring formed by different elements, then they are called as heterocyclic. At least if there is a difference of one non-carbon atom, they are called as heterocyclic compounds. Example: 5-membered ring with a nitrogen as an heteroatom, then they are called as pyrrole. Then 5-membered ring with a sulfur as a heteroatom, thiophene. 5-membered ring with the oxygen as the heteroatom, furon. 6-membered ring with the nitrogen as an heteroatom, pyrroline. Like that, different names are there, different hydrocarbons are there which are heterocyclic in nature. Again, homocyclic hydrocarbons are further classified. Homo means they are made up of only one type of ring atom. They are called as homocyclic in nature. They are further classified into alicyclic and aromatic. Aromatic are further classified into benzonoid and non-benzonoid. Aromatic means they are going to contain a aromaticity, Huckel's rule. They are going to follow the organic compounds. They are cyclic in nature. They are made up of only one type of ring atom, and they are going to have alternative single and a double bond. Such compounds we are going to call it as aromatic compounds. Alicyclic means they are homocyclic, no doubt. They are made up of only one type of ring atom, but they are not aromatic. They are not having the unsaturation. They are saturated. Such compounds we are going to call it as alicyclic. Cyclic in nature, but aliphatic. Aliphatic means they are satisfied by a single bond. Therefore, they are called as alicyclic. Again, when you consider aromatic, benzonoid and non-benzonoid. Benzonoid means aromatic compounds, if they contain the benzene as one of the ring atom, then we are going to call it as the benzonoid. Apart from the benzene ring, some other ring compounds are there which are homocyclic, then we are going to call it as non-benzonoid. Alicyclic compounds are also called as cycloalkanes or cycloparaffins. As the name indicates, they are homocyclic in nature, but they are not going to have a double or a triple bond. They are saturated homocyclic hydrocarbons. Such compounds we are going to call it as alicyclic compounds. These are saturated compounds in which no doubt that they are cyclic in nature, but they do not contain double or a triple bond in their ring. Such compounds we are going to call it as a cycloalkanes. They are going to behave like a alkanes, but they are cyclic in nature. Therefore, we are going to call them as cycloalkanes or cycloparaffins. They have the general formula CnH2n and the first member with the 3 carbon atoms: cyclopropane, cyclobutane, cyclopentane, cyclohexane, etc. Similarly, aromatic means these are the compounds which going to have homocyclic in nature. They are cyclic in nature. They are made up of only one type of atom, but they are going to have an unsaturation containing a double or a triple bond. Such compounds we are going to call it as aromatic compounds. Those are also called as arenes. AR stands for aromatic. ENEs means they are going to contain a double bond. Therefore, they are also called as arenes. Here they are going to have a special stability over other unsaturated hydrocarbon. Those compounds we are going to call it as aromatic compounds. So that may be a benzene containing only one benzene ring. Other 2 benzene rings which are fused at ortho position, they are called as naphthalene. Then you are going to have phenaphthalene. All these are called as aromatic hydrocarbon and they are homocyclic in nature. Similarly, if they contain one of the benzene ring, then we are going to call it as a benzonoid compounds. They are fused ring system, but they are going to contain at least one benzene ring in them. They are cyclic in nature, they are homocyclic in nature, and they are benzonoid in nature. They are going to contain at least one benzene ring in them. Such compounds we are going to call it as benzonoid compounds. Similarly, non-benzonoid compounds, they are not homocyclic in nature. No doubt all the ring atoms are made up of same atom, but they do not contain a extra stability. Aromaticity is not exhibited by them. They do not contain a benzene ring in them. Such compounds we are going to call it as non-benzonoid compounds. So this is the way we are going to classify the organic compounds into different manner based on the structure. It may be open chain or closed chain. Open chain means saturated or unsaturated. Closed chain means homocyclic or heterocyclic. Homocyclic means they may be aromatic or alicyclic. Like this we are going to classify them. Remember, carbon has only 4 bonds. The meeting of 2 personalities is like the contact of 2 chemical substances. If there is any reaction, both of them are transformed. Therefore, generally when we meet 2 personalities, when you meet 2 reactants, they combine together to form the product. Here also both the reactants, they get transferred themselves to form the product. Similarly, when we meet 2 personalities, always we have to get transferred with each other. Thank you. All the best.